Hello students, I welcome you all in this session of quick solution for All India ACAS test series for JEE Advanced 2020, test 5A, paper 2, code ENF, subject physics, test dated on 8th of March 2020. Straight away, let's start with question number 1. Here in question number 1, in the arrangement shown, rails are smooth, rod has negligible resistance and applied force F is constant. Then this is the particular arrangement. The capacitor is connected here and the rod is actually being pulled by a constant force F. So let's figure it out which one of the given options are actually correct. I would say, let's say at any particular time instant, the charge on the capacitor is Q and the rod moves with the velocity V along this direction and the current flowing along this direction is I. So I would say the value of I to be equal to definitely dq by dt, and q at any time would be how much? It must be the potential difference that is actually appearing across this region into the capacitance. So I would say q must be equal to VBL into C. So dq by dt, that is actually I would say BLC into dV by dt. Now another equation. Acceleration of this rod M, it would be F, that was acting along this direction, minus magnetic force that is in opposite direction. It must be ILB. I is how much? It is BLC dV dt. This is the value of I into LB. This is the total force acting in this direction, must be equal to M dV dt. Or I would say F must be equal to B square L square C plus M into dV dt, or the acceleration of the rod, how much it is? It is F divided by B square L square C plus M. This is the acceleration. So I would say the rod must be moving with the constant acceleration of F divided by M plus B square L square C. And once it is having the constant acceleration dV dt, so I would say the charge on the capacitor must be increasing and the current would be how much? It would be BLC dV dt. So rod moves with constant velocity is the wrong option. B is the correct answer, and charge on capacitor increases with time. That is the correct answer. So we are getting option B and D as the correct answer for question number 1. Now let's proceed to question number 2. Here in question number 2, in the circuit shown, when switch S is closed, then capacitor is initially uncharged. We know that when at t is equal to 0, the switch would be closed. This will not offer any resistance and the current through the resistance would be maximum. The current will be how much? I naught, and it must be E divided by R. So at that time, the thermal dissipation across the resistance would be maximum and the current would keep on decreasing, and finally at t is equal to infinity, the current in the circuit will be 0 and the charge in the capacitor will be maximum. So let's see the options now. Rate of energy stored in capacitor first increases and then decreases. Well, I would say this is the correct answer. First it actually increasing and finally the rate of energy stored will become 0 and the capacitor will be charged completely. Rate of energy stored in capacitor first decreases and then increases. This is the wrong option. Rate of energy dissipation in resistor first increases and then decreases. We said that it would keep on decreasing continuously. The rate of dissipation in resistor decreases continuously is the correct answer. So we are getting option A and D as the correct answer for question number 2. Now let's proceed to question number 3. Here in question number 3, a charged particle of mass m and charge q is projected with velocity v0 into a transverse cylindrical magnetic field B as shown in figure. v0 was given to be root 3 qbr divided by m. Then we need to figure it out how the charge would spend the time in magnetic field and the distance it will travel there in the magnetic field region. Well, at least we know that if the charged particle completes the circular motion in the magnetic field, then the time it would take, that will be 2 pi m by qb. So effectively we need to figure it out that how much angle it is subtending there at its center of curvature. If we know that angle, we will be able to find out the time the particle will be spending there in the magnetic field. Okay, so here the velocity was to be how much? Q B R by M into root 3. So the radius of curvature, I would say R dash, it will be mv by qb. So it is m divided by qb, and v was given to be qbr divided by m into root 3. So qb will cancel out. So the r dash will become root 3 into r. That means if this is the magnetic field region and the particle enters from here, then from this point onwards it will move on a circular trajectory whose radius will be r dash. So I would say that this is the path it is traversing. Since this value is r dash, if I draw the center line from here, this is a circular path here, I would say, then definitely this angle here, it is theta, I would say. So r dash divided by r dash was how much? Root 3 r divided by r would be tan of theta, or I would say theta is equal to how much? It is 60 degree. That means if this is 60 degree, 30 degree, and this also is 30 degree, and this is the center of curvature of this circular path. So particle is effectively subtending an angle of pi by 3 at the center of curvature. So the time it will take to move from here to here or in magnetic field would simply be t is equal to 2 pi m divided by qb divided by 1 by 2 pi into pi by 3. So this one will cancel out, or it is pi m divided by 3 qb is the time the particle would be there in the magnetic field. Option A is the correct answer. Now the change in momentum will be how much, and the distance traveled in the magnetic field, and the angular deviation. Definitely the angular deviation is how much? It is actually 60 degree. So this is wrong option. Change in momentum, it will be mv was along this direction, and finally it became mv along this direction. So this minus this one would be this vector. This is mv, this is mv, and this angle was how much? 60 degree. So the magnitude would still be mv itself. So change in momentum, or in fact the magnitude, would be m into v naught. M was how much? M, and v naught was qbr divided by m into root 3. So I shall have root 3 qbr as the change in momentum. Now the distance traveled in magnetic field, this is the angle here, fine, 60 degree. So how much is the distance? It is r theta. R was how much? It was root 3r, and theta was pi by 3. So effectively pi r by root 3 is the distance traveled in the magnetic field. So this is also the correct answer. So here for question number 3 we are getting option A, C and D as the correct answer. Now let's proceed to question number 4. Here in question number 4, two blocks of mass m and 2m are connected by a spring and placed on a smooth surface. A constant force F is applied as shown. Then we need to find which one of the given options are correct. Maximum compression, maximum elongation, acceleration of center of mass, and minimum acceleration of block of mass 2m. Well, first I need to find what is the acceleration of center of mass. So definitely it would be F divided by 3m would be a naught. At the time when all the particles shall have the same acceleration as the center of mass itself, that would be the state of most equilibrium situation of individual particle with respect to center of mass itself. So the maximum shifting would definitely be twice of that shifting that actually has occurred up to that time. So I will calculate the instant when this body shall have the acceleration equal to the acceleration of center of mass itself. That means F minus k delta x naught would be equal to how much? 2m into a naught, that is F divided by 3m, or F minus 2f divided by 3 would be equal to k delta x naught, or it is F divided by 3k would be equal to delta x naught. This is the extension of the spring when individual particles are in a state of equilibrium with respect to center of mass. That means these particles have been extended so that the extension now is how much? Delta x naught. So it will further extend up to here and up to here with respect to center of mass, and it will keep on oscillating about this point, and this mass will keep on oscillating about this point with respect to center of mass. So the maximum extension, I would say, that will be twice of this delta x naught. So delta xm is actually 2f divided by 3k. So option B is actually the correct answer. And as I said, it will move to here and up to here. This is the particular configuration when the spring was in its natural length. So effectively, there would not be any compression in the spring. Acceleration of center of mass, we found it to be f divided by 3m. So these two options are actually wrong option. Minimum acceleration of block of mass 2m is. The minimum acceleration of this block would be at that particular instant when the spring would be extended to its maximum value. So I would say the total force acting here, it would be F along this direction, and total extension was how much? It was 2F divided by 3K. So the force in backward direction, it would be 2F divided by 3 must be equal to 2m into A dash, or A dash is F divided by 6m. That is the answer for the minimum acceleration. Option D is actually the correct answer. So finally, for question number 4, we are getting option B and D as the correct answer. Now let's proceed to question number 5. In question number 5, a small block of mass m is released from rest from the position shown. The wedge has semi-cylindrical groove as shown. Friction is absent everywhere. When the block reaches at the bottom, at that instant, we need to find that how the speed would change and the displacement of the wedges there. Well, by the time the mass m moves to the lower point, all the potential energy of this small mass will now be shared as the kinetic energy of this mass and this wedge. So let's say this small mass is having the velocity v1 along the direction, and the wedge is having the velocity v2 along this direction. So clearly mv1 must be written down as 2mv2, or v1 is equal to 2v2. So the total potential energy initially mgr, kinetic energy now m v1 square divided by 2 plus 1 by 2 into 2m into v2 square, and it would be v1 square divided by 4. So mgr must be equal to 1 by 2 mv1 square. This 1 by 2 mv1 square, 1 plus 1 by 2, it is 3 by 2. So this would cancel out, and we are getting this answer as 4gr divided by 3 square root is actually v1. So v1 is how much? It is 2 root under gr by 3, and v2 is, it is gr by 3 square root of that part. This is the velocity of mass m and 2m respectively. So option A is actually the wrong answer, and option B is the correct answer. Normal force on block is 4 mg, and displacement of wedge. Well, this is the small mass, and the center of mass on this line for the wedge will be here. So definitely by the time it will reach at this point with respect to the wedge, definitely it must have shifted by this much of the distance. So this much of the distance will be how much? It will be r by 3. So I would say option D is actually the correct answer. This is from the shifting of center of mass. Now normal force on the block, I would say the net force acting toward the center with respect to the wedge, it will be n minus mg must be equal to m. V square is the velocity of this block with respect to wedge. So the velocity with respect to wedge is how much? It is 3 root under gr by 3. So v square will be, it will be 9 into gr divided by 3, and it is m v square divided by r. So this one will cancel out. This is 3. So normal force is coming out to be 4 mg. So we are getting option B, C and D as the correct answer for question number 5. Now let's proceed to question number 6. In question number 6, a particle of mass m is released from the position shown in a smooth tunnel along the diameter of Earth. Mass is m, radius is capital R. Then we need to find out how the speed would be at the center, time period of oscillation, and the gravitational potential energy. What we know, at any particular distance from center, let it be x, then the force on mass m would be how much? G capital M small m divide by r cube into x. This is the restoring force. So divide by m would be minus omega square x. Okay, so from this equation we are getting the value of omega to be equal to root under g by r. So the time period would be how much? 2 pi root under r by g. So definitely B is the correct answer here. Speed at the center. At this point, the speed would be how much? Maximum value, A into omega. A is the amplitude, that means this is the amplitude here. It would be R, and omega was? It was root under G by R. So definitely it is GR square root of that. So option A is also the correct answer. Time period of oscillation, this one would be the wrong option. Gravitational potential energy at C. We know that at this point, the gravitational potential at the center happens to be minus 3 by 2 gm by r. So the potential energy would simply be m multiplied with this factor. That means u at r is equal to 0 would be minus 3 g capital M small m divided by 2r. So we are getting option A and B as the correct answer for question number 6. Now we shall proceed to question number 7. Here in question number 7, the plane surface of a plano-convex lens mu is equal to 1.5 and radius of curvature 20 cm is silvered. An object of height 2 mm is placed at a distance 30 cm. Then we need to find the nature of the image and the distance and size of the image. Let's first try to evaluate where the image would be formed by the refraction from this curved surface. So the image distance would be mu2 by v, I would say. Mu2 is how much? It is 1.5 v minus mu1 by u. This is u is equal to minus 30. Must be equal to mu2 minus mu1. That is 1.5 minus 1 by 2. And r, it is 1 by 20. So 1.5 v must be equal to 1 by 10 here. This is 1 by 4 minus 1 by 3. Or 1.5 v would be equal to, it is minus 1 divided by 10 into 12, or v is coming out to be 15 divided by 10, 10 into 12 with negative sign. This one will cancel out and it is coming out to be minus 180 centimeter. That means after the first refraction, the image would be formed at minus 180 centimeters. So this mirror will experience as if the ray is coming from this point. So after reflection from the mirror now, it seems like the ray is actually diverging from 180 centimeter from this side. So this surface would again refract the ray which is actually coming from 180 centimeter on this side. Mu by v, mu here it is 1 divided by v minus on this side it is 1.5 and the distance is how much? 180 must be equal to, it is minus 1 by 2 and this radius of curvature is minus 20 this time, so it will be 1 by 20. So 1 by v must be equal to 1 by 20. Here it is 1 by 2 minus 1.5 divided by 9, or it is coming out to be 1 by 60. So we are getting the image distance v on this side. It is how much? It is 60. So definitely the magnitude of magnification would be 2. So I would say image is real. Image distance is 60 centimeter and size of image is 4 mm. Originally it was 2 mm and it must be multiplied with 2, so it becomes 4 mm. So option A, C and D are the correct answer for question number 7. Now let's proceed to question number 8. In question number 8, Two parallel plates are dipped in a liquid of density ρ and surface tension T. At a small separation d as shown in figure, if liquid rises up to a height h, then angle of contact is. In this situation, if this is the one view, I would say, and I'm taking this much of the length as L, and this is the contact angle, so definitely on this side the force that will be acting in upward direction because of surface tension, it would be T into L into cos theta because of one surface, and for the other surface it will be 2. This much of the force must be balancing the weight of this much of the liquid there. It has actually been raised by how much? H height. So the total volume of this much of the liquid, it will be H into L into D. H into L into D. This is the volume, and the mass would be how much? Rho into G would be the weight. So cos of theta would come out to be, this one will cancel out, it would be H rho D into G divided by 2t. So we are getting theta to be equal to cos inverse H rho D G divided by 2t. That's the answer for question number 8. Option B is the correct answer. Now let's proceed to question number 9. Here in question number 9, three rods of same cross-section area A and thermal conductivity K, 2K and 3K are joined, and two free ends are maintained at constant temperature as shown. Here it is 120 degrees Celsius, this is 10 degrees Celsius. Let the thermal resistance of this part, I would say, it must be equal to how much? It is 1 by K L divided by A. About this much of the portion, it will come out to be L divided by 2K into A, and for this one it will come out to be L divided by 3K into A. If I'm saying this part to be equal to R, then this one would be how much? It would be R by 2 and this is R by 3. So R1 is equal to R, R2 is equal to R by 2 and R3 is equal to R by 3. So total effective thermal resistance, it would be R 1 plus 1 by 2 plus 1 by 3, 1 plus 1 by 2 plus 1 by 3, or it is R, this is 6 and this is 3 plus 2 divided by 6, and it is 11 R divided by 6. This is the total effective thermal resistance. So the heat current that will be flowing across this region, let it be I is equal to delta Q by delta T. It would be 110 divided by 11R into 6. This 11 will cancel out. So we are getting this value to be equal to 60 divided by R as the heat current. Now the temperature T1 is 60 degree. We need to find the temperature here. It would be T1, I would say 120 minus I into R1. So I was how much? 60 by R, and R1 is R. So I'm getting this answer to be 60 degree. So option A is actually the correct answer. And the temperature T2 is here. It would be how much? It is 10 plus I into R3. I was 60 divided by R, and R3 is R divided by 3. So this one is 20. So I'm getting this answer T2 is equal to 30 degrees Celsius. This one is also the correct answer. Heat current through rod is 20 kA divided by L. How much was the heat current effectively? It is 60 divided by R. Fine. So 60, and R was L kA. So it is 60 kA divided by L. So option C and D both are actually the wrong option. So we are getting finally A and B as the correct answer for question number 9. Let's proceed to next question now. Here in question number 10, which of the following statements are correct regarding the photoelectric effect where mu is greater than mu threshold? Mu threshold is the frequencies there, and the incident frequency is higher than threshold frequency. So definitely there would be some photocurrent. Now, photocurrent is directly proportional to intensity. Higher intensity means higher number of photons are incident, and so higher number of photoelectrons would be ejected. So definitely the photocurrent will be on the higher side. Stopping potential increases with increasing frequency. Increasing frequency means now the ejected photoelectrons shall have the maximum possible energy corresponding to the higher frequency itself. That means the higher stopping potential would be there to stop those of the current. So option B is also the correct one. Option C is saturation current increases with increasing intensity. Well, higher intensity would yet again I would say that it is because of the higher number of photons now. So definitely larger number of the photoelectrons that would now be ejected. So saturation current would increase with increasing intensity. Stopping potential increases with increasing intensity. Stopping potential depend on the frequency only. So we are getting option A, B and C as the correct answer for question number 10. Now let's proceed to question number 11.